Okay, good day. So we are looking at Euclidean geometry. This is 2018, February, March 2018. It reads in the diagram PQRT. PQRT is a cyclic quadrilateral. So we are saying that this is a cyclic quadrilateral inside in a circle such that PT is equal to TR, PT is equal to TR. We have got equal chords there. PT and QR are produced to meet at S. TQ is drawn. SQP is 70. Calculate with the reasons. The size of T1. Now, small questions like this, I'm going to try to answer there. So size of T1. Now, when you're looking at T1, it's, and we are having a cyclic quadrilateral. T1, it is equal to 70. Why? Because exterior angle of what? Cyclic quad. Now, then we have Q1. Q1 now, what we have Q1 is equals to 70 divided by 2, which is equals to 35. Why is it not? Equal angles. Equal chords subtend equal angles. Now we are saying TP is equals to TR. So here what we're having here, equal chords subtend equal angles, meaning to say this angle here is equal to what? Is equal to this angle here. So what it means that TQR is equals to TQP. That's what it means, okay? You must always remember that. Then we are given that if it is further given that PQ is parallel to TR, PQ, where is PQ? PQ is parallel to TR, okay? It's further given that. Now, calculate with the reasons the size of T2. Where is T2? T2 is here, and here we say it is 35. Here is 35. So what does it mean here? T2 alternate angle. It forms a Z angle. Alternate angle. So we are saying T2 is going to be equals to Q1, which is equals to 35. Why? Alternate angles are equal. Okay, so alternate angles are equal. Then the last part here, 7.22, is saying prove that TR over TS is equal to RQ over RS. Okay. Now what we need to do here is that we see that we are using proportionality theorem here. So we're going to say, we're going to use what? We're going to use, we know that TP, let's start with what we have, the smaller side, TP over TS is equal to QR, which is RQ over RS. But why is that? Proportionality theorem. Proportionality theorem says if we have a triangle here, and the line that divides our triangle is parallel to one side of the triangle like that, it means that these two will be what? B, C, D, E. So it means that this triangle here will be proportional to what? To this smaller triangle here. That's what it means. Now, what we have here is that we're going to say now we are given that TP is equal to what? TR. This is given. So therefore, TP we are going to replace with TR over TS is going to be equals to RQ over RS. Okay, so it's proven like that. So you get your 2 marks there. Now let's move on to the next question here. It's saying in the diagram, PR is the diameter of a circle. So we are given that is the diameter of a circle with the center O. ST is a tangent to the circle at T, okay, and meets RP at what? At S. SPT is X and S is Y. Now we're asked to find that, determine with reasons Y in terms of X. So we want to find y in terms of x. Okay, want to find y in terms of x. So what are we going to do here? Here we already know that this is 90. Why is it 90? Because it's what? Because of what you call angle in the same circle, angle subtended by the same circle, okay, or angle in the same circle, angle subtended by the diameter is 90. So what are we going to do here to find what is it, y in terms of x? We need to find this angle here. We need to find this angle here. So how do we find this angle? Well, we know that for us to get this angle here, we know that we're going to say P, which is x, S, P, T is equal to T, P, T, R plus P, R, T. Why is it like that? We are saying this angle here, outside angle here, is equal to sum of this angle here. Why are we saying that exterior angle? Exterior angle of what? Of triangle. Okay, that's what we know, because remember, exterior angle of a triangle, when we have a side like this, when you have an angle, this angle here should be equal to sum of this. So if we have x and y here, we know that to find whatever we have theta, will say it equals to x plus 1. Because both of these two, they do add up to get 180. Because this is a straight line here that should give us 180. This is also a triangle that should give us 180. So in other words, we are saying if we were to put alpha here, we will say alpha plus x plus y should give us 180. Okay, but also we find that we could say also alpha plus theta to also get 180. That's why we are saying that. So these two here will be actually equal. That's what we mean by that. So these two actually are equal. So what are we going to do now? X, since this one is 90, this one should be 90 minus what? This R. So R, we're going to say SPT, which is X. X should be equal to 90 plus R. So it means that our R should be equals to x minus 90. That's what we have there. X minus 90, which is R. Now, when you have got R, we know that R is equals to T is equals to STP. So STP is equals to R, which is equals to x minus 90. Why are we saying that? Turn chord theorem. Turn chord. So turn chord theorem. Then here, what are we saying here? We are saying if T is equals to x minus 90, sum of interior angles of a triangle, we get what? We get this one is now it's x minus 90. Sum of interior angles, we must get 180. So we are going to add all of them. So we're going to say your S plus your P plus your T, it must give us 180. So we're going to say what is our S is Y plus what is our P is X. What is our T? It's X plus x minus 90 should give us 180. Then here, y should be equals to 180 plus 90 minus 2x, because x plus x is going to be 270 minus 2x. That's our answer there. Okay, that's how we get to our answer there. I hope you guys understand the step that we're taking here and also understand this this rule of exterior angle. Okay, now let's move on to the next next question, which is question 9. Now, question 9 is saying in the diagram, DEF is a quadrilateral. We are given that it is a quadrilateral. DE is 45. DE is 45 and GF is 80. GF is 80. The diagonals GE and DF meet at H. So they meet at H. GDE is equals to FEG. GDE is equals to FEG, and DGE is equals to EFG. DGE is equals to EFG, EFG. Okay, so now we are told that give a reason why DEG is similar to EGF. EGF. Now, why is it similar? Because see that this angle here and this angle here are equal, and we were also told that this angle here and this angle are also equal. So it means that the third angle should also be equal. So what do we say? Equiangular. So remember, for similar triangles, angles should be equal. So similar triangles should be angle. That's what you must fight to prove. All sides should be in proportion. So here we can also say angle. The angles are what are equal. Now calculate the length of GE. We want to find the GE. What is the length of GE? Now we are already given this. What is it? These two that they are actually similar. So we say 9.2. With 9.2, what are we going to say now? We're going to say, if these two are similar, we're going to say DE, which we have, over DE over EG, over GE should be equal to, since they are in proportion, we have got, what else do we have? GF should be EGE on the first triangle here over GF. Now we know that this one here will lead us to what? Will lead us to DE, we have it 45 over GE we don't have, is equals to what? Is equals to GE over 80. Okay, then you cross multiply, you find that you will find that GE times GE squared is going to be equals to 80 times 45. And what are we going to do now? GE should be equals to root of 80 times 45, which will get as what? Root 80 times 45, we get 60. So our answer is 60. So guys, remember here, when you are given this, remember, I just want to show you something here. When you are given, when you see that your triangles are similar, what it means here, it means that you take the first letters over the second, the first letters or the second as well. So we're going to say DE over EG should be equal to, you take the second letters as well, and the second letters, the last two letters, EG over GF. Then you take the first and the last, which is going to be equals to DG over EF. So that's how you actually write when you're talking about similar triangles. And also when you're talking of similar triangles, if you are to be asked which triangle is similar to another triangle, please, you must write corresponding with what way they equal, the angles that are equal. So you can see here, we start with E here because E is equal to D. So we say D and D is equal to E, the angles. Then you say D, or write D first. Then what other angle is equal? We are told also that G, which is that, is equals to what? Is equals to what? DGE is equals to EFG, is equals to EFG. That's what we're having here. Then what else? So we feel that the G is in the last G, which is equals to F, is on the last one, F and G. Then E is equals to G here. E, which one? E is equal to G here. That's what we have. So that's how you must write when you're writing your what you call your proportional triangles. Now, calculate the length of, okay, we found that. So it's 60. Now we ask to find what? We ask to find, prove that DEF, DEH is similar to FGH. Okay. If we ask that, prove those two, they are similar, what must we do? I'm just going to solve here. It's 9.3. Okay. So we are told that DEH is similar to FGH. H. So what are you supposed to do here when you ask such a question? Okay, guys, what you're supposed to do here, you must prove that angle D is equal to angle F. And also angle E should be equal to angle G. And angle H should be equal to angle H. That's what you're just supposed to do here. So what do we do now? We come with our question here and say, all right, now, what do we have here? We're going to say, okay, for the first one here, we find that H, so D, so this should be actually similar. So how are they similar? Now, DHE is equals to GHF because they are vertical opposite angles. Vertically opposite angles are equal. Vertical opposite angles are equal, so we have one angle down now. What another angle can we talk of here? Because we want to find DEH. D, where is D here? D and F. This is, sorry. So we have DEH, DEH, similar to FGH, FGH. Now, we also know that we're told that from the previous, because we know that these two triangles were similar, the previous one, the one that we're given here, we already know that the E, which is DEH, should be equals to HG or FGH, FGH. This one here, because why? Because we already told that proportional, what called similar triangles, that DEG is similar to EGF. So these angles are equal. Already we have that already. So the third one now should be obvious because the third angle. So what do we have? We have got ED now, which is D. So we're going to say now HDE is therefore equal to HDE is therefore equals to GFH. And when we say that, why are we saying that? Because it's the third angle, or sum of triangles equal to 180. So third angle or I'm going to say sum of angles equals to 180. Okay, that's what we have. So sum of the both angles should be equal, or 30 angles should actually be equal. Okay, that's what we have. Because there's two angles already, we found that they are equal. So the 30 angle should also be equal, should be equal to both. They must give us same total. Okay, that's why we are saying that. Now, the last question now is saying 9.4 is saying, Jens, calculate the length of GH. Now 9.4. Calculate the length of GH. Where is GH? GH. We want to find the GH now. We want to find the GH now. So what must we do now? We already know that we have found, we have this, we have got, we already have the sides already that we have here. So we already know that DE, so DE over FG is equals to EH over GH. And we are looking for what? We are looking for GH. That's what we are looking for here. We are looking for GH. So what must we do now in that case? What must we do now in that case? We know that here now, and we know that H, we already given that GE should be equals to what? It's schist. We already found it done. We already found that. So the reason why we are writing this one is because of what is it? The similar triangles. So we are saying it's because it's given that what is it? Your DEH should be is similar to FGH. That's what we have. Now, here we can now say our DE is 45. Then our FG is what? It's 80. Okay. Then now we have our FEH. And we have got what? We have got GH. But here is a trick here. There are two ways that you can deal with this type of question. Okay, guys? There are two ways that you can deal with this question. You can either express this EH into GH in form of GH, which we say, so the first one here, we're going to say 45 over 80. 45 over 80. Can we not simplify that? 45 over 80. 9 over 16. Okay. So we can simplify that. 9 over 16. Okay. So here we can now say equal to what is, how do we get now GH? How do we get EH? Sorry. EH we say, to find EH we say 60, which is the whole of GE minus GH over GH. That's what we have there. Okay, that's what we have there. Then what we do now, we cross multiply. It's gonna be equal to 9GH is equals to 16 in bracket 60 minus GH. Then if we are to solve here, we find that we bring your GH this side. It's gonna be 16GH, 16 plus 9, what do we get? We get 25. So it's gonna be 25GH is gonna be equals to 16 times 60. We get 960. Then GH should be equals to 960 divided by 25. We get 38.4. 38.4. That's what we get. So this the length is 38.4. What about the other method that I said we can actually use? We can also use the proportion, what we call our ratios. We can also use the ratio here. Now, what we see here is that we see that they are in the same ratio. They're in the same ratio. So we see that GH DE over FG is equal to EH over GH. That's what we have there. So in this case now, what do we know here? We know that this is more like 9s/16. That's what we have. So if we are to have a set line here of what is it, of this line here, G, and we have got H, and we have got what? We have got E here, and we are saying this is 9, let's say 9K s/16K in the same line. And we know that the length, total length for this is actually 60. That's what we have there. So if we have that, we want to find GH, which is the bigger part. So we'll say GH, we're going to say 16 over 16K over, we add the 2 because over total parts is going to give us 25 parts, which is 25K, is going to give us what? It's going to give us multiply this times 16, which should give us GH. So GH is small part here, so it's a bigger part, 16 over the total times 60, which is the total length here. Then what do we get there? The K and K will cancel, so we're actually saying it's 16 here over 25 times what? Times 60. We get the same answer, which is equals to GH should be equals to 38.4 units. Okay, so here units. Okay, done like that. So that's what you're actually supposed to actually do. Either way, you can still get your answer. Okay. Now let's check the last part here. What do we have? We have got question 10 here saying in the diagram, O is the center of the circle with A, B, C drawn on the circle. Okay, A, B, C drawn on the circle. I'm going to take you here. A, B, C drawn on the circle. So you have got A, B, C here. Now, prove the theorem which said that BOC is equals to 2A. Now, here what you simply do, we divide here. You divide. Now, when you divide here, you are dividing your O is 1 and O2. Then also here, you can also say A1, or you can use X. You can use X and what? And Y, like that. So those two are different. But now understand something here, that these one are radians. They are all radius. So it means that the base angles should be equal. That's what it means. So here we also have X, here we also have Y. That's what it means. Okay, that's what you must know there. And again, here we're going to use this exterior angle, guys. We're going to use this exterior angle that where we say this angle here, which can be theta, should be equals to X plus Y. The one angles inside. Okay, I want you must understand this exterior angle of a triangle is equal to sum of opposite interior angles. Now, here we have got, we're going to say in this case, now we're saying A is equal to what? X plus Y. Okay, but also what we see is that BA, which is X, A, so B is equals to X, Y, because of O, B, and what? Equals to OA, what do we call equal radii. The radius are the same. The radius are the same. So what does it mean now? It means that to find O1, we will say O1 is equal to sum of these two here, which will get 2x. Okay? Then we do the same for this idea. We know that C is equals to Y. Why is that? Because we know that our OC should be equals to what? OA equal radii. Equal radius. Then from there, we know that O2 is equals to therefore 2Y. That's what we have there. So what is now BOC? BOC should be equals to, BOC, we know that we're going to say it's going to be equals to O1 plus O2, which is equals to 2x plus 2y. But now we can factor out now, because 2 is common, we're going to factor out 2, which is x plus y. What is x plus y? It's a. So it's going to be BOC is equals to 2a. That's what we have here. So it's already proved that your interior angle the center is twice angle on the circumference. Okay, I hope you guys understand this, and I wish you the best in your practices. Thank you so much. Bye bye.